Mr. Ashutosh asked the students of his class to draw a scalene triangle ABC such that AB is less than BC, BC is less than AC, and AB, BC, AC are all integers. He also told his students that the semi-perimeter of the triangle is 6. It is given that semi-perimeter of triangle is 6 centimeter. So I have the value of perimeter as how much? 12 centimeter. Now we have to form a scalene triangle, such that the semi-perimeter of this triangle is 6 centimeter and all sides are unequal and integers, right? Distinct integers. So what is the maximum number of different non-congruent triangles he will get? Yeah. For a triangle to exist, I know sum of any two sides, sum of its any two sides must be greater than the third side, right? So third side, this is the universal property, universal identification of triangles, right? This is the most basic property of triangles. For a triangle to exist, sum of its any two sides must be greater than the third side. From this property, I can say that the longest side of a triangle must be less than the semi-perimeter. Semi-perimeter. How can I say this? Because if longest side, I'm assuming that longest side is A, right? And other sides are BC. If this is equal to semi-perimeter, then other two side must also be equal to semi-perimeter. And in this case, triangle cannot exist because sum of these two sides must be greater than third side, right? So this A, if length of longest side is S, this B plus C must be greater than S, right? So this is the way to solve these questions. So semi-perimeter is 6. So we have to take integral cases where the longest side, I'm assuming longest side to be A. This A is how much? This A is longest side has to be less than 6. So first case is I'm assuming that the integral value of this side is 5, right? Now I'm writing the values for B and C because it's a scalene triangle. Scalene triangle. So we cannot take these sides as equal. Now, if the measure of this side is 5, now the sum of other two sides must be how much? 7 because perimeter is 12. Now the sum of these two sides must be 7. So I can take other side just less than this value, which is 4. So C becomes 3. So this is a possible scalene triangle, right? I cannot have any other combination, right, of numbers such that their sum is 7 and individual values are less than 5 because I've assumed this as longest side. If I take 7 as 1 and 6, it will dilute my purpose, right? Then longest side becomes 6, which is not the case. So I cannot get further cases for longest side as 5. Now I am assuming the longest side as 4. Next, if longest side is 4, sum of BC must be how much? 8 because perimeter is 12. If this is 8, I can get the sum of 8 as, if I take this side as 3, it becomes 5, which is not possible because I've assumed the longest side as 4. So you can see that there are no cases possible from A equal to 4 onwards, right? So only one such triangle is possible in which sides are 5, 4 and 3, right? These sides are, this is 5, this is 4 and this is 3. Also these are distinct integral values. So correct answer to this question is we will get a maximum of only one congruent triangle, non-congruent triangle.